So I'm doing positive inducible regulation. So it starts over here with our promoter and our regulatory gene, which is going to make our inactive activator through transcription and translation. So our inactive activator protein is right there. Under the right conditions, our small effector molecule, or our substrate, is going to bind to this inactive activator and activate it. So now we have our active activator protein. This is going to bind to our activator binding site, which is upstream from our promoter. This is going to induce RNA Pol II to bind to our promoter site and start transcription. So one of our two analogies, we're just going to throw these all on the board now, is actually in the lac operon. One of the regulatory mechanisms it uses is positive inducible. So when CAMP is in high enough concentrations, it'll readily bind with CAP, and this will turn into our active activator protein. It will bind to our binding site, and our RNA Pol II will bind to our promoter site, and that will start transcription for our lac operon. Now let's move on to our second analogy. All right, so our second analogy has to do with my dog Koko. So here's how it's going to work. My hand is going to be the inactive activator protein. He's going to have treats for an activator that will activate my hand, and then with the treat in my hand, we'll be able to start transcribing some tricks. All right, so as you can see, empty hand, not activated. I can't get Koko to do any tricks because he's stubborn. All right, so we're gonna come over here. We're going to get some treats. So now I have a treat. This is my substrate or my small effector molecule. And now this attention is our RNA polymerase binding, and now we can start transcribing some tricks. So Koko, sit. Good boy. So without the small effector molecule, I can't make Koko do any tricks. With my small effector molecule, I can make Koko do tricks. Shake. And that's it.